Hey everyone, this is Eric from Kansas again. Come with another update on battery building. This is my father-in-law's 12-volt battery that I'm making for him. Got it charging now and assembled. I let it balance out. I'll connect it in parallel for several days while I waited some parts. And they were all around 3 volts, just like maybe 0.005 volts, under 3 volts. And they're all going up nicely. I think there's like a 0.01 volt difference now on one of the cell packs. But yeah, just charging up right now very slowly. Just using the regular automotive kind of a smart charger for car batteries really, but works the same. At 2.4 is for the amp rate that it's put into the batteries. So it's been charging since about 12 hours now or so. I estimated about 18 or 19 hours to charge up. But let's see what the voltage is per cell. I'll try to do this one-handed. But I got the first cell here I'm going to do. Oh, I think turned off. There we go. 3.306. 3.3056, 3.303, and here's the one, the biggest difference, 3.296. So it's about a 0.01 difference between all the cells. So anyway, it's still charging up. Got about 0.3 volts to go. Well, whatever this thing is going to charge. I think it's set to AGM, so it's going to charge it to probably 14.2, 14.3. I'm pretty sure. But it's reading 13.7 right now. But anyway, that's that. Once we get it charged up, we'll do a capacity test, and yeah, we'll see how it goes. I'm still waiting on a battery monitor to do that. I should get that in for pretty soon. And for an update on the battery that I'll be building for our system, I've just got bus bars over here all cleaned off. I think I mentioned some of the videos. They had just some nasty, gunky oil wax on them, so I've got those cleaned off. The wax, probably don't need that since I won't be dealing with lead or acid, whether it's AGM or flooded anymore. So it shouldn't corrode hardly at all anymore. But anyway, yeah, I'll be cutting these up, and I'm waiting on some other ones. I'll need quite a bit of them. I'll need quite a bit of these, them cut up like this. 50 or 60 or so to build the battery I'm looking at. So it'll be a 200 amp hour, 24 volt nominal battery. So looking forward to that. But I'll give an update on that too. Again, I'm waiting on some more of these for my father-in-law. He's got some as well. And then once I get those, I'll start cutting them up. I'll clean them up and cut them up and get that going. So it's still got ways to go, but I'll give you an update. And we'll talk to you later. All right, folks, we're back again. Finally got all the parts that I needed to make another continuous video, part 3 or 4, I can't remember. But so got my father-in-law's battery together here, 100 amp hour, 12 volt nominal lithium iron phosphate battery. Got the Dally BMS here, got in a milk crate carton that we've had for years. I'll use it to carry it to his house. So we're gonna do a load test on this thing. So I got a little cheapy battery monitor here. It's probably not the most accurate thing in the world, but it'll do what I need it to do. Give me a good idea of what the capacity is. This is my first capacity test, probably officially, but anyway, so it should be fun. This deal is going to go inside this box here that I've got some from a previous project. We're going to run it all through this cheapy Chicago Electric 12 volt, 1000 watt inverter. It's just a modified sine wave thing. And we're going to use this heat gun I've got here. So anyway, so I'm going to get it all set up here, and stay tuned. All right, everyone, I'm going to try to do this without kids bothering me, but got the battery set up here. Got the box all set up. Battery monitor's on. This is a 100 amp DC rated breaker that's got turned on, so this is on and reading a voltage here. But I haven't turned on the heat gun yet. I've tested this inverter out, so I'm gonna turn that on here. So once it settles out, it's going to pull, I don't know, 17 watts or so. So anyway, I'm going to go ahead and run this, and I'm guessing it should take a couple hours to run this battery down, and then we'll see what happens. But they had measure the voltages of the battery before I get started here, the resting voltages. One of them's a little high, 3.47 versus 3.33 of the other ones. So that's like maybe a weak cell. It was that one was a little bit lower when I was charging it up, but now it's higher, so I'm guessing it's a little bit weak cell, one of them. Anyway, so I'm going to turn this on, and then I'll turn the heat gun on here, and we'll get going here. Focus, terrible focus. Okay, it's pulling 800 watts out of the battery. Milliamp hours really going up. There. 64 amps, 12.6 volts. All right, folks, we'll see how this goes, and I'll give you an update when this is done. All right, folks, I'm about 15 minutes in. Hopefully you can hear me. I'm still going strong. Actually, this battery voltage has gone up 12.5. It was 12.4, and I confirmed that with my multimeter here. It was at 12.68 6 minutes in. Now it's at 12.7, and the individual voltages are holding strong. This one, which I thought was weak, is holding strong in there, and this one of these middle ones is getting a little bit lower than the other ones. But anyway, 18 minutes in, 18.8 amp hours, high 60s in amps, and 850 watts still. So anyway, that's where we're at. So I forgot that these wires right here coming out of this box are just 6-gauge wires, so they're getting a little bit warm. They're probably, I guess, 90 degrees Fahrenheit, maybe 95. This 4-gauge wire is getting a little bit warm, might be like 75 or 80. None of the bus bars are warm, which is good. Pulling almost 70 amps. So looking good there. Oh yeah, and these wires in the BMS are warm too. Probably not quite as warm as this one though, which is interesting. It's probably because they're welding cable, thinly stranded wire, able to handle a little more current, I guess. But you know, they're warm, but they're not. You know, they're like 85, 90 degrees Fahrenheit maybe. And the BMS. Sorry, I'm gonna go over here. The BMS is, I mean, I can feel maybe a little bit there, but it's not bad. Maybe around a little bit higher than room temp. All right, another update here for you. About 40 minutes in, about 46 amp hours. Things are getting a little warmer. These 6-gauge wires are probably about maybe 100 degrees F right now, which is still not too bad. It's just kind of warm to the touch. This 4-gauge wires, about the same. Still no heat in the bus bars, which is fantastic. This inverter is maybe about 90, 95 degrees F, somewhere in there. Not too bad. Just kind of like a comfortable warm, you know what I mean. But anyway, just wanted to give an update here. And just FYI, these 6 gauge wires here, I'm just using what I found, what I've had around the house. I did go buy this 4 gauge wire just today for this test so I could reach the inverter, because I didn't have anything else that could reach it and it had the right connections. But anyway, just using what I got. I know it's not the right gauge, but it is what it is. And just maybe I just wanted to match this wire here. I don't know. But anyway, we'll keep you updated. Yeah, folks, I'm not sure if this thing shuts off at 11 volts, but I guess it doesn't. I'm measuring 10.9 at the inverter. It's going down quick. I'm assuming it'll shut off at 10.5. Well, it's giving me some beeps. I bet it's going to go off at 10.5. We'll see. The blower on the heat gun is definitely slowing down. Yep. Maybe it'll show up at 10 volts. I don't know. .7, 2.78, 2.685, 2.5. The last cell, this cell here was 2.5. Yeah, it's 2.4. I'm gonna go ahead and shut it off. Oh, there it went. Okay, we're done. 97.8. And right at 1.2 kilowatt hours. Okay, interesting. Well, folks, it's just below 100 amp hours, but I only charge this battery up to about, well, on my battery charger it said 14.2, and on this voltmeter, my other one, is like maybe 13.9 or 14 volts, so it wasn't completely charged up. So I'm guessing that's where the difference is. And maybe also the differences in the these wires here. There was definitely some voltage loss between those. So, you know, hey, we're right at 100 amp hours essentially, according to my guesstimates. So I'd say that's pretty good, folks. Hope you enjoyed the test here. And yeah, I'm gonna go ahead and get this over to my father-in-law, and so he can use it for his sump pump and whatever else he wants to use it for. So I'll be trying to do some more capacity tests of the battery I'm putting together for our system, and we'll keep you updated on that. We'll catch you later, and grace and peace be with you. Bye for now.